So we're looking for the zeros of this function, and since it is a degree 4, we know that we will have 4 zeros. So we start with the rational zeros theorem, and we list the possible rational zeros first. To list the possible rational zeros, we're going to take all the factors of the constant in the polynomial, which would be the -2, and we'll divide that by all the different factors of the leading coefficient, which is +5. So all of the numbers that divide into the constant would be ±1 and ±2. All of the numbers that divide into 5, all the factors of 5, would be ±1 and ±5. So now when we actually make our list, we would have 1 over 1, which would be ±1. 1 divided by 5, which is ±1/5. 2 divided by 1, ±2. And 2 divided by 5, ±2/5. So now we have a list of only 8 numbers that we want to try and find one that works. So we could either plug 1 into our function to see if it results in a 0, or we could go ahead and do synthetic division with 1 to see if we end up obtaining a 0 remainder. So I'm going to go ahead and try my synthetic division with 1. Remember, you can always pause the video and try it yourself first. All right, doing synthetic division with 1, it does not look like I'm going to get a remainder of 0. So 1 does not appear to be a 0. So now we move through our list. Let's move on to -1. So now we'll try our synthetic division with -1. Aha, it appears that because we get a remainder of 0, that -1 is one of our zeros. So as you begin to make your list, you could list one of your zeros is -1. Okay, so now we know that there are going to be 3 more. So if we take a look at our row of synthetic division, this represents 5x to the 3rd power minus 22x squared plus 13x minus 2. And if we were to set that equal to 0, we want to solve this equation and get 3 more answers, which will be my last 3 zeros. Unfortunately, this cubic does not factor by grouping. So we're stuck. We have to do synthetic division again. Now this is the point where you could use your calculator, go ahead and type your p of x, your function, into your y equals, and then just use your calculator to try some of these other possible rational zeros. So I would try 2, and then I would try -2. And then I would move on to the fractions last. Try 1/5, try -1/5, and then 2/5 and -2/5. So I would recommend pausing the recording right now to go ahead and try those keystrokes on your calculator to make sure you're comfortable with them so that you can find another rational zero that will work. It looks like 2/5 is another 0 of this particular function. So now, rather than doing synthetic division with the original coefficients of the polynomial, we can stack our synthetic division and use the 5, -22, 13, and -2, the coefficients of our new polynomial, and do our synthetic division with 2/5. So bring the 5 down. 5 times 2/5 is 2. Add and get -20. -20 times 2/5 is -8. Add to 13. 5 times 2/5 is 2, and aha, we do get a remainder of 0. So we can add that to our list. 2/5 is another one of the zeros. Now, looking at the bottom row of synthetic division, these numbers really represent 5x squared minus 20x plus 5. So now we need to set this equal to 0 and solve this equation to get our last two zeros. Now the question is, how do we solve 5x squared minus 20x plus 5 equals 0? And this is where everyone may solve it a little differently. Some people may try to factor it right away, some might try to complete the square, and some might try to do the quadratic formula. I would recommend noticing that all three terms are divisible by 5, so we have a GCF, and factor out the 5. That leaves us with x squared minus 4x plus 1. So really, we're just focused on solving x squared minus 4x plus 1 equals 0. Remember, you could think of it like this. Essentially, you could go ahead and divide both sides of this equation by 5, because 0 divided by 5 will give you 0, and that's why we're left solving just the equation x squared minus 4x plus 1 is equal to 0. So it does not factor. However, this would be a good case to complete the square. And the reason for that is because when you look at the b value, which is -4, it's an even number. So when we complete the square, we have to divide the b value by 2 and square it. And it's easy to divide -4 by 2. So I recommend completing the square. So to complete the square on this quadratic, you want to first move the constant value to the other side. So that will give us x squared minus 4x is equal to -1, because we'll subtract 1 from both sides. And now we're ready to add a number to the left-hand side, and we must add the same number to the right-hand side to keep our equation in balance. And the idea is that we want to add a number that will create a perfect square so that we can factor this. So when completing the square, in general, we want to add b divided by 2 squared to both sides of your equation. The b value divided by 2, and then you square it. So for this equation, that means we'll have our -4, divide that by 2, and square it. And that's what we're adding to both sides of our equation. So half of 4, or half of -4, is -2. When you square it, you'll be adding 4 to both sides. And again, the reason for this is because now x squared minus 4x plus 4 can be factored. So that will factor into x minus 2 times x minus 2, which is the same as x minus 2 squared. The right side, -1 plus 4, will just give us 3. And now we're ready to undo our quantity squared, so we'll square root both sides of the equation. That'll leave us with x minus 2 equals plus or minus the square root of 3, and then finish solving for x by adding 2, and you get 2 plus or minus the square root of 3. So these are our remaining two zeros. So now we have found all 4 of our zeros: -1, 2/5, 2 plus the square root of 3, and 2 minus the square root of 3. These are our 4 zeros. Lastly, we want to write our polynomial in factored form. So we can use the zeros to do this, and there's 2 different ways of writing this particular polynomial in factored form. So when we look at the 0 of -1, then if you turn that into a factor, the factor would be x plus 1. Look at 2/5, which is our 0. It would come from a factor of x minus 2/5. 2 plus the square root of 3. If you take the 0 and you're creating your factor, it's always x minus that 0. So we would have to write it as x minus the quantity 2 plus the square root of 3. And then lastly, and I'm slightly out of room, so yours would continue on to the right, but my last factor would be x minus the quantity 2 minus the square root of 3. And these would be our 4 linear factors. Now the last thing we have to do here, though, is we have to make sure that our leading coefficient matches the original function. Because if you think about actually multiplying these four quantities out, we would have an x times another x, and lastly a fourth x. That would give us 1x to the fourth power. The leading coefficient would be a 1. But look at the original function. You need the leading coefficient to be a 5. So if you want to write your factored form this way, you need to go back and put the 5 in at the beginning. That's our leading coefficient. 5 times x plus 1 times x minus 2/5 times x minus the quantity 2 plus rad 3 times x minus the quantity 2 minus rad 3 would then be our factored form. Now, or the other way of writing this, if you don't like the idea of going back and putting your leading coefficient in, then you could basically take that 5 and embed it in the function inside one of those linear factors. And that would look like this. Think about what it would look like if you took the 5 and you distributed it to the factor x minus 2/5. What would result would be the factor 5x minus 2. So rather than writing the factor x minus 2/5 and then including the 5 in front as our leading coefficient, you could actually write the factor as 5x minus 2. And then all the other factors remain the same. So this would be our second alternative for writing the function in factored form, where we have 4 linear factors.